Thanks everyone for joining us today. Thanks to Brendan Wilson for having me back so soon after the last one. I think it was just 6 weeks ago I spoke to you all. I did a little intro on Fabric then. Today we're going to dive a little deeper into the data warehouse portion of Fabric. I'm going to give you some tips and tricks. If you've been doing data warehousing for a while, if you've been doing, say, database development on the SQL Server side, the first maybe 30 minutes here, these may be things that you might have thought of before. But I know with Fabric being new, we're getting new data professionals into the field, so I want to make sure, we're lifting everybody up as much as we can. Right. So this is me, Chris Hyde. My pronouns are he, him. I'm a Microsoft Data Platform MVP from Albuquerque, New Mexico, where I also lead the Data Platform group. I'm actually not there at the moment. I'm in Texas today. So the important bit on this slide is on the bottom right. If you really like this session, get on Blue Sky, get on LinkedIn, tell everybody how good the session was. If you don't like it, or if there's more stuff you wanted me to talk about that I didn't get to, that's what the email's for. A little bit about Albuquerque. We're known primarily for the TV show Breaking Bad. And if you ever wanted to live in the Walter White house, well, your chance is, it's your lucky day. For the low price of $4 million US dollars, you too can become the most visited house in your neighborhood. All right. With that, so here's what we're going to talk about. I'm going to give a brief overview of Fabric, just real brief, because I know we did this 6 weeks ago, but I don't know if everyone on the call was there then. Talk about where data warehouse fits in. And we're going to talk about designing for good performance for data warehousing. We'll then talk about designing to take the most advantage of Direct Lake mode in Power BI. And then we're going to look at kind of some workarounds for some T-SQL limitations that we have today. And these are based on the ELT patterns that I use. They're based on kind of my exercise of taking some code for one of my clients. And the promise has been that we can lift and shift into the cloud, right, in Fabric Data Warehouse because it's all T-SQL based. Well, of course, things are never that simple. So we'll go through the gotchas that I've run into and how to get around them. We're a pretty small group. So if you have any questions, just go ahead and take yourself off mute and jump in. We can be pretty informal today. I can't see the chat with the view I've got here. So if somebody else can monitor the chat, and if you don't want to come off of mute, maybe ask a question in the chat, and Brand or Wilson can pass it forward. Bobby, you've got your hand up. That I can see. Do you have a question?
Yeah, I'm just wondering, is it possible we can have a recording of this for future preference? Because I'm getting new into Fabric, so I think this would be a good reference for myself.
Sounds really interesting. Okay.
Yeah, so we
did you guys turn on the recording yet?
Yeah, so we turned on the recording already, Bobby. So we'll share that after we upload it on YouTube. It'll usually take about a week or two, maybe 3 at the worst case, and we'll let you know what where that location is through the discussion chat there.
Can you throw the YouTube channel in the chat, if you don't mind? And that way I can I can subscribe and all that good stuff.
Yeah, let's us look for that right now. Let Chris get going, and we'll send you the link there in a bit.
Okay, thank you.
All right. So again, this slide is lifted pretty much from exactly what I talked to you all 6 weeks ago, which is Fabric is Microsoft's next generation. It's the all-in-one data analytics product. It's got everything built in. It's got your data warehousing, obviously, that we're going to talk about today, but it's got data engineering. It's got data science. It's got reporting and data visualization in Power BI. But it's being presented like as software as a service rather than platform as a service. So let's say you were trying to do all this, say, in the Amazon cloud, right? There's Chris. You would maybe use Apache Airflow for your orchestration to move your data into the cloud. And then you're using Databricks to transform it. Maybe you're landing it in Snowflake. And then maybe you're using Tableau on top of Snowflake for some visualizations. Well, it's a lot of different moving parts you've got to bolt together. The idea of Fabric is let's put all of those in one piece of software. And let's do all the connecting behind the scenes, make it seamless for the end users. So it's an all-in-one solution rather than having to do those other pieces. Now I know Amazon and GCP is starting to roll out their own all-in-one solutions as well. But I think Fabric was a little bit first to the scene with that. The other thing they're looking at is we're making one copy of data in one lake. In the past, people have spent a lot of time moving data from one location to another. Right? You copy it to one service, you translate that, you dump the translated data somewhere else, then you do an import into Power BI, you're making another copy. The idea is, you want to make one copy if it's possible of the data. So here's the idea of what this looks like. All the data sits in this one lake box. I'm not sure if you can see the mouse pointer too well, but this one lake box here. And it doesn't matter whether the data is in your data warehouse, your data lakehouse, your CustoDB for real-time intelligence, or your Power BI data set. It's all being stored in that Delta Parquet format under the scenes, and it's separated from the compute. So any of these compute engines, whether you're using T-SQL, like in a data warehouse, or Spark Pool, like in data engineering, or analysis services, aka Power BI or KQL, you can hit any of these different Delta files with any of the compute. And the compute's not running all the time. You just spin it up when you need it. And when you're done with it, turn off the compute. So you're actually, you end up kind of sizing your Fabric solution to an average workload rather than whatever the peak is, right? So it's going to save a lot of money, hopefully. Remember, back in the old days, you had to have a beefy ETL server to do all your ETL processing in that short window at night. So all the reports are ready in the morning. And then, that same server would then sit idle or at 5% for the rest of the day. It was kind of a waste of money. But the idea is we'll size this to the average load, and then all those peaks and valleys of usage during the day, we're going to smooth those out. But that's really kind of the overview of Fabric. So then Fabric Data Warehouse is within that. We want to have a data warehousing experience that is based on standard Microsoft T-SQL, because that's what people are used to using a lot in the data warehousing world. It's a good way to get people into the cloud, but it's also a good way, like we'll take those tables from the business system that are probably in third normal form, right? We're going to flatten those out. We're going to make them really easy to report against. We'll put them into facts and dimensions, and we'll talk about what those are later, if those are new terms for you. We'll just make it really easy for reporting. Just like in the box SQL Server, we can do stored procedures. So we can encapsulate our code, save it to the server, rerun the same piece of code with the same plans again very efficiently. But then again, just as we saw here, even though we're using T-SQL, our data is still stored in the Parquet format with the Delta layer on top of it. Because of that, it's queryable through any of our query tools, including, most importantly for most of us, Power BI. So the first tip, and this is something that you don't always think about, especially coming from the on-premises world, is just the latency between the different parts of your solutions, right? Because a lot of us, if we've been doing data premises or data warehousing in the on-premise world, often our business system and our data warehousing system, they're like next to each other in the same rack. So there's no latency. But here, our business system might be on premises or it might be in one region. Well, let's try and pick a region for our Fabric solution as close as possible to all the sources that we're going to bring in or push out from, right? So we got to think about the latency between our client, like my desktop, and the compute engine, right? Because all the data's got to go, if I'm writing a query, the results have to go from the region that Fabric is in to the region that I'm sitting in. We also have the ability to do shortcuts, which are, it's a data virtualization tool. Like I can point Fabric at an Amazon S3 bucket, and Fabric thinks it's within inside that Fabric solution, which is awesome. But you've got to think, like, if I've got a lot of S3 buckets in US East, maybe I don't want to put my Fabric server in US West, for example. Also, any large result sets, like if I'm writing a query with a lot of result sets, we've got to think about that coming back to us. So a couple things there. Not only do we, of course, want to minimize the distance between the regions, but any result sets larger than 10,000 rows, we can't use the Fabric GUI for. The Fabric GUI will only return 10,000 rows. So what we can do is we can use our good old SQL Server Management Studio. We can use Azure Data Studio, and we pour one out for Azure Data Studio going away next year, but also VS Code, right? Those are actually going to be a little bit faster because of the encryption protocol that they use, the TLS, was it 1.2 now, I think? So that's actually a little faster than returning to the screen in the Fabric GUI, but also you don't have that limit of 10,000. So so even though we've gone to this new solution in the cloud, we're still using Management Studio like some of us have been using for 25 plus years or more. And so we got to think about our table design in our data warehouse. So again, if data warehousing is new to you, the term star schema might be new. The idea is that you have a central fact table that has countable data. And then out from that, in a spoken hub kind of situation, are your dimension tables, the things you are slicing and dicing by. Now, in no LTP system, what you have is just like each of those like lookup tables then get subdivided into further out lookup tables, and everything's really in third normal form. So when you want to write a complex query, you sometimes have to join 10, 12 tables together or more. We don't want to do that. We don't mind like repeated data across the different rows. We're not as worried about data integrity as we are in a business system, because the business system is the thing taking care of that data integrity. And so, we want to break it into fact and dimension tables. And I think I have an example on the next slide. But we're also going to have some integration tables that you're using for sort of pre-processing your data. So here's the famous New York taxi cab data set. And actually, when I did the diagram, I've got some of these relationships the wrong way around. So forget about the actual direction of the relationships here. But you have your central fact in the table. This is the thing we're counting. We're counting number of taxi trips. We're counting, how much did the taxi trips cost in total. But then we're slicing and dicing by. So what was the cab medallion? What was the date? The week, the month, the year that you took that trip. Where did it start from? Where did it end? What's their license number? So you can slice and dice all those things. Basically, like you think of a SQL query, anything that you're doing a sum or an average on is in the fact table. Anything that you're doing the group by is one of the attributes in your dimension tables. So that's another way to think about that if the term star schema or the term facts and dimensions are new to you. So fact is your sum and dimensions are your group by, basically. So within that, this is nothing new, but we still want to use the smallest data type possible, right? We want to minimize I/O when we're writing queries and putting data in, but the idea of data warehousing is we're analyzing data that we've got, so we want to put it in once and then hit it with lots of queries to analyze it in lots of different ways, right? So we want to use the smallest data type possible. Now, even though we're using T-SQL, not all the SQL Server data types are supported by Parquet. So I think we'll talk about that on the next slide too. Let's see. Okay, I don't really have any examples of that there. So like TinyInt doesn't exist in Parquet. So you would need to use a small int. The money data type doesn't exist. So you would need to use a decimal of the appropriate precision. Date time doesn't exist. Only date time 2 and date time 2 with a precision of 6. So if you have different date time requirements, you may have some issues here. Use varchars instead of fixed length. Use not null instead of null. Again, this is all about how Parquet is designed rather than like SQL warehousing in general best tips. If you have like a pipeline tool, so like if you're, let's see if I have, do I have time to do this demo? I think I'm running a little later than I expected, so I won't do the demo. But if you run through the, like just importing a CSV into Fabric, and run through the base tools to turn it into, a table, all the text fields are going to be varchar 8000. It's not going to tell you that. You don't have a way to change that when you're building the pipeline. It's just going to automatically do that for you. And then it's going to be slower than it needs to. So just validate what gets created by those tools. And it's great to be able to like point and click for one-off solutions. But if you're really building going forward, you're going to want to, just as we do today, build your destination schema, correctly, and then use the pipelines or data flows, but make sure you've got that destination schema defined. Right, Brent, you got a question?
So you're talking about text fields getting changed to varchar 8000. Is it only the text data type, or if you were using long like 4000 varchar in your source system, will that still be kept at 4000?
Any text or character data type.
Oh, so even like if you're using, if you have something that's defined as varchar 128, it winds up being varchar 8000. Okay. Ooh. Okay.
So just when you're using like certain tools.
Okay.
Right, because the tools are designed for what they call citizen developers to do things like point and click,
Right.
right? Which is great. It allows people that don't have like some of the the years of professional experience to be able to interact with Fabric very quickly. So it's great from that standpoint. But in terms of like building efficient permanent solutions, that doesn't that's not helpful.
Right.
But if you build your destination schema first and then pipeline into that destination schema, then you're going to be okay.
Okay, that makes sense. So figure out what you want to build, instead of just wildly dumping stuff in and then going like, oh, now I have a billion records with and all the postal codes are taking varchar 8000.
Yeah,
It's slow. Okay. Thank you.
All right. So there's a link here on this slide. You'll follow to learn more about the different data types. Go to into more detail than I'm looking at. Enough. Use that instead. Actually, probably even use small int. Right. If you're using a decimal, don't declare it just as a decimal, because then it's going to use the default precision and scale, which I think is maybe 38,0. Declare it with the right precision and scale that you want to use. Right. If you've got an ID field, like if I'm getting a surrogate key to join my tables together, use an integer for it. Don't use a character field to join on. Again, use varchar in the fabric world. Use not null where possible, and don't use those 8,000 length varchars. Brent, did you have another question, or you just still get your hand raised?
Oh, I still had my hand raised, but I do have a dumb comment, if I may. With your being an integer data type, aren't we just building a Y2 billion problem? I mean, some of us survived Y2K, and I might not have my mortgage paid off by Y2G, so it would be good to know that there's a
If you're worried about still being around in the year 2 billion, then I'll allow it. But honestly, for me, I'm not too worried about that.
that's a reasonable somebody else's problem.
Yeah, I'm sure we're going to be on Fabric version 128,000 by then. So, not too worried about that. All right. So for the next piece, I want to talk a little bit about Direct Lake, and we've got to build in some design limitations for that. So this is what Direct Lake is. It's a Power BI mode where today we've kind of got the choice between the purple and the green method for Power BI. We either do a direct query, which goes straight back to the source system, or we've got the import mode, which is it's going to be a lot faster, but we're creating a copy of the data, and your data is only as up to date as when you did that last refresh. Which for a lot of this is no big deal. We're quite happy. That's a good trade-off. The speed for not having real-time data. Those of us that really need real-time data, we might do the direct query mode. But today that's slow because we don't have a lot of we might be hitting Parquet files. We might be hitting today in Power BI like an underlying SQL Server systems. What Power BI is introduced is this direct link method. So there's no midpoint here because it's going through. It just goes straight from Power BI to those Delta Parquet tables. And if this is designed correctly, you can see really good performance. You can see like real-time performance almost as good as the performance you get on the input. So great feature, But as I said, we've got limitations. Now these are detailed here at that link, but these are some of the big ones. That if our semantic model, aka Power BI data set, but yeah, what the new and improved term for that is semantic model. That model has tables from more than one warehouse, or actually from a warehouse and a lakehouse, right? It's you can't put that in direct link mode. If your model has calculated tables, calculated columns, that's no bueno. If your relationships between any of your tables are based on date time columns, that's no good either. Now, that would be just a bad design anyway, because you want your fact dimension tables to be based on integers if possible. That's your joining, that's going to be the most efficient. But yeah, if you had a compelling reason to build something on date time columns, then you wouldn't be able to use direct link. And then if your key column data types don't coincide, or they're not unique, so you have to have a unique surrogate key. You have to, if the foreign key, if the primary key is an integer, the foreign key has to be an integer, so on and so forth. You can't have, primary key of a dimension being an integer, foreign key in the fact table is a bit int. That's going to be direct link mode. Also, this next one is the big one for me. If a query needs data from a view in the model, then you're going to have to fall back to direct query. Because see, if we look here, we're looking straight at the tables. A view is kind of an in-between object at your SQL endpoint. Right? So there's no SQL endpoint here. We go straight to the table. So any translation that's done in a view, there's no place for that here. So we're going to fall back to direct query here. And there is this little wrinkle about SSO authentication. One thing this does for me is it changes some of my patterns if I want to use the direct link mode. So my current patterns for where I align are I contain my tables and two schemas called fact, should I clicked, fact, and div for dimension. Then on top of those, I create views and a data dimension, which has the views of the fact table, and a lookup, data schema has views on the fact schema tables, and the lookup schema has views against dimension tables. So I do this for, I think, three main reasons. Let's see if I change that number as I'm going through. So first reason is like my end users, they don't necessarily understand facts versus dimensions, but they all understand the concept of data versus lookup. That makes sense to them because that's how they're used to thinking about data patterns. So the second reason is there's a lot of plumbing in my fact and dimension tables. We'll show an example of that in a second. But those fields that I use for metadata, these fields that I use for comparing rows to determine data changes. Right? Those are not really useful for most of the end users. So in my views, I leave those out. And then the other reason is for for what we call role-playing dimensions. So let's say I have an appointment fact table about doctor's appointments. Right? I might have an appointment date. And then a completed date when the appointment was completed, and then a rescheduled date if the appointment was rescheduled to a different date, and a canceled date if the appointment ended up being canceled. Well, if all of those just go back to a table called date, and somebody's just picking a column called year, inevitably somebody picks a canceled date when they wanted an appointment date, or vice versa. So I'll make a view called appointment dates. And all the fields in there will have like appointment date year, and
and another view with canceled date year, canceled date view name, canceled date year field name. Right, so it becomes much more difficult for the users to
pick
pick the field they were intending to take.
But
But
you know,
like we've talked about,
if
if we want to use direct lake,
yeah,
yeah, we can't do that. So if I need to leverage direct lake, I'll just have my data and look at schemas and I just make tables in there. And
then
then
those
those
four
four
views
views on top of my data table,
I will
actually materialize as four different tables.
So
So there's a lot of duplication there,
but if
but if we need that speed benefit that direct lake provides, that's how we've got to do it. And of course, I'll always have an ETL schema or an ELT schema that has all my orchestration items, my pre-processing items, things like that.
Are there
Uh,
are there tricks you've learned to training your users to think like it's really cool that you've got the data and lookup schemas, but are you going to have to retrain your users to support the direct query?
Not really, because if they're using Power BI,
then they
then they won't see any difference. They'll just think it's really fast. It's more for the users that are actually writing SQL queries against the tables.
So you only have to retrain the developer cohort with best practices.
Yeah, and it's really just like
these
these 8 fields at the end of the table. Just ignore them.
Is
And it's the other big piece is start from the fact and go out to the dimensions. Don't start querying the dimensions. Because that leads us into if you have slowly changing dimensions, you're going to see duplicates in a dimension. You're going to see multiple rows for the same person table.
All right.
So just because I know slowly changing dimensions might be new to some of you, that's there are more than just 3 types. This is just ways to track changes to our attributes within our dimension tables, aka the things you're going to group by. There's more than 3. These are the 3 most common. So a type 0 attribute would be something that can't change. So like day of the year or day name would be like that. Because in a date table dimension, the 4th of March 2025 is always going to be a Tuesday. It can't ever be anything else. So that can't change. Then the next one is a type 1. So where we update those changes in place. We don't need to keep a historical record. So I'm working for a college right now. If let's say I'm also attending the college, I'm going to have a record of the student table. If I come back next semester and I decide I want to be Christopher instead of Chris, then that's okay. That name is going to be reflected back as Christopher through my entire academic history. Right? But type 2 is where we set a version. So if I come back the next term and I want to change my gender or the ethnicity I identify as, and this, we see this happen both with people's self-identification changes, but also they make mistakes on the forms, right? But ultimately, these things do get changed for a small percentage of students from term to term. And we need to be able to keep track of that because our state and federal reporting in the US, before anything changes there, but our current state and federal reporting, needs to have, okay, what gender did, the state identify as the time at the time. So I don't know now.
dual records, but we're sending things like, this semester we had 10,500 women, 10,000 men, and 500 chose not to identify, something like that. So we always have to, like, for historical purposes, to be able to recreate our historical, be able to go back. So what we would do is we put a start and end date on those rows. And when something changes, we end date the row, we add a new row with today's start date. And then we'll always, when we're joining from our fact tables to our dimension tables, we make sure we're picking, okay, am I picking the current row? Do I need to pick a historical row to join to? And once you put the right key in, any joins that you make coming out from that fact table will just magically have all the historical information in it. You can also mix these within the same dimension table. It doesn't mean that the entire table has to be type 1 or type 2. You can have some attributes be type 1, some be type 2. So because of this, these are my metadata fields that I add. I have a source system name, source system key, because it might be that, here's an example of my current college. We have our building data, and different buildings the college owns. Well, we have some information coming from our building system of record that the facilities use. We have some information coming from the student system that say where the different classes are held. So we have both records coming into our dimension and identified this is coming from our data student system versus our PPD facility system. And here's the key value for that building within that system. For change detection, I use hash values. So I just hash together all of my attributes that are type 1. And I create one hash value. So when I'm looking at detecting change, it's not where field A in the source is not field A in the destination, or field B is not field B, or field C is not field C. And, my student dimension has like 80 fields in it right now. That's awful to maintain. If I hash them together, I just say, hash 1 in my destination is it hash 1 of the row still? Okay. Yep, it is. No change needed. Or no, there is a change, so I need to do an update. Same thing with my type 2s. And then because the type 2s, we need the start and finish dates. We've got those as well. With quick flag to make those easy to query, saying this is the active record. And one last piece I always like to have, when was that record in the system last updated? Do you have another question there on site?
Yeah, question, Chris. Very informative about this piece here. Just thinking about the hash value that you listed there, is there any value of hashing the key as well as in addition to what you proposed there? Any pros and cons around that?
So no, because the key, you wouldn't do that because the key can't change. Right? If the key changes, it's automatically a different record. Right? The key is the, like within that source system, the key is the thing that identifies that record. So if that changes, that is necessarily a different record. Yeah. So one example of this that I do is in all my stored procedures, I have a little comment header. Like these are the data elements that are they're the business keys. Sometimes this is just one, sometimes this can be multiple. Here are all the ones that have type 1 logic should apply to. Here are all the ones that type 2 logic should apply to. Sometimes even the type 1s, like in this case, we have a flag whether something is STEM, so science, technology, engineering, and math. Right? But that is based on this on the code. So I would really need to hash these fields because if this changes,
these might change as well.
Right.
So then I go down and I use CTEs, so I have data is my last CTE, what puts everything together. You see how a lot of these are translations. But then when I go down to my hash code, I can just put in the name of the field. And then when you do need a field separator, to handle nulls, to handle, just weird data, exceptions. I have a friend here, Donald Duck, and I have another friend here called Donald Duck. And if I hash those together with no separate, let's say last name field, first name field, and we're case insensitive, I hash those together, no separator. It's you get the same value. So you always have to come up with a separator like that to make sure that your hash is going to be good. Thank you.
Well, while you're there, do you have separate tables where you store the metadata of first name is a type 1 and last name is a type 2, that kind of thing? Like where do you manage your metadata?
Could. At the moment, my main pattern is just putting that in comments.
Okay.
But if I was going to generate code based on that metadata, I would put it in the table. I have a pattern that I use. We'll see that on my. I have a refresh here. Here's my student one. Basically, all this code from here down is a pattern that could be generated from metadata. So that if I had that, all this stuff in tables, and here you see one that actually has multiple. If this was all stored in tables, I could generate this entire rest of the code piece for my insert update procedure. Just out of metadata. And there are definitely people doing that. We tend to see that more on the Lakehouse side, I think, the people that are comfortable in doing that kind of code generation would rather use a more procedural programming language like Python than query language with some procedural bits added to it.
Right.
But
you certainly can do that. There are lots of people out there doing that.
And then if you ever change a type 1 dimension into a type 2 or vice versa, I assume you have to go back and recalculate hashes for all the affected records.
Yeah, you do. You do. That's the drawback. That's the payoff for not having.
Right, but it's one of those things that happens rarely. And you get paid for the hash value every time you have to compare. It delivers value.
Yeah, so there is my type 1 detection instead of what's the that case 40 different. Yeah. So it's a trade-off. It's a little bit tougher to maintain from the if you do make a change, if you do add a new column, which hopefully is more rare. Or if you decide that something needs to go from a type 1 to a type 2, you're making some changes and you're recalculating the hash values.
But
it's also this detection or this change detection is much more efficient than 40 more statements. It's going to run much quicker as well.
Does that
doing a hash is not that difficult of an operation, but doing 40 or comparisons, the engine doesn't like that.
And you have to you effectively do the comparison once and store the result. Does that tie into your indexing strategy? So does a clustered index apply here? And would you wind up putting non-clustered indexes on your hash values?
It would in the
I don't think so. Hash value, right?
let me first say that fabric indexing is an entirely different
Okay.
thing than on-premises indexing. So so a lot of what you would know about indexing doesn't apply in Fabric because indexes work very, very differently on complementary files.
Okay. Maybe that's a good next session topic.
But I think, that would be that would be a good one actually. But in when I have this in on premises, so you'll see how I join my targets to my source.
Right.
So my non-clustered index would have source system name and source system key as nodes, and then include the hash value.
Right.
Right, and then that's as a non-clustered index. I may have other indexes, but that's a non-clustered index that directly supports this change there. This change detection algorithm, and it's going to speed that up a lot to where it's worth having the extra storage. And of course, name is usually a pretty small character. Key is, almost always an integer, so that's pretty efficient. And, this is in this is like a 64 byte. I think this is a 64 byte field in most on premises for the kind of algorithm that I use. Fabric has to use a different length for the key values, unfortunately. But this is, and I'm using, if we go back to one of my get datas, where was I? So I was in my class get before. And see that I'm using SHA-256 as my hatching algorithm, which gives us a 64 byte length binary. So you can imagine, even apart from all of the ores, right, 40 ores, comparing 64 bytes, comparing all the bytes that are in the length of all these fields, much more efficient. When we look at the student one, with our 40 fields, even more. All right. The other thing I do is I have what I call Sentinel values, and I know there are other terms for these, but in my dimensions, I always have values for unknown and for missing. And I use a -1 and a -2 for those. So that way, all of the key columns in my fact table are populated. Even if I don't know what the dimension value should be, or if it's missing, and we don't know what it is. Like if I have a fact joined to my student table, and there's a record mismatch somewhere, I would have an unknown student -1. But if I'm doing it to my grade tables, and the classes are still going on, we would expect those to be missing. Because they're not there, we would expect them to be there. So I usually treat those two as distinct members. And then in every dimension, there'll be a row for unknown and a row for missing. I had one client where they were crazy. They had 5 of these different Sentinel values, and it made the logic very difficult for maybe not a ton of added value. But I knew why they did it, so it made a lot of sense for them. But I just stick to the -1, -2. All right. So with all that being said about how I set my warehouse up, right? That's where I get into taking what I do with lift and shifting into the cloud. So first problem I have no
temp tables
in
in
fact.
Fabric.
We go
We go
over
over to the class
get
get
data
data that I'm looking at.
I
I
think
think this is one where I'm using.
Yeah.
Yeah.
You
You can see just for this dimension, there's a lot of complicated logic,
right?
right?
Could
Could I write this in one all stinging, all dancing, set-based operation? Probably. Could anyone else at my client debug that?
No.
No.
I'm
I'm a consultant. They bring me in because they don't have people with those types of skills.
not
Not
only
only that,
could
could I debug it 6 months from now when I go back to make a change and haven't been dealing with it all day? No.
Right?
So I've got to use templates.
The
The other thing that I use
is
is we go back to that insert update. I create a temp table,
and
and then I type the results from my get data procedure into that temp table. And then I do those comparisons. And I do that, for a couple of reasons. The main reason is just to keep this stuff I call the plumbing. This is what needs to happen, the insert and update. The actual coming up with all these different translations, that's business logic. So I like to keep the business logic and the plumbing separate. One thing that allows me to do is then I make a change in the we go back to the class, and I'm skipping between student and class. That's just what. So let's say I make a change to my class business logic. I can just execute that procedure, see what my result set is going to be, without having to worry about turning off inserts and updates to see the results. So it makes it very easy for me to evaluate changes.
all
All good.
we
We don't have temp tables.
in fact.
So what I have to do instead
is
is I have to physically materialize a table, and maybe I'll use the schema component, maybe I'll use that ETL schema I talked about before, but I'll have to physically materialize a table in that schema.
Yeah.
I'm not really going to show a demo here because I think you can easily understand there. Let me pull up a different version of this talk, actually. I will swap that in before I, push this out for you guys to have the link. So let's slide share from here. So as we've said, it makes the complex business logic simpler, separates the business logic from the plumbing. We've got our workaround, but we've got the potential of concurrent updates. If I physically materialize the table, multiple processes could be hitting that table at the same time. So I'm going to watch out for that.
Right?
There's some ways to deal with that. I mean, one way is just to make sure you only ever have one ETL process scheduled at the same time. You don't let anybody else have update rights on it. So that's that limitation. Here's the good news. Temp tables are coming. In theory, they might be here by the end of the month. So hopefully I'll be able to get rid of this slide. Maybe convince your boss that you can hold off on doing that migration for another month.
All right.
So here's my second limitation. That insert into exec. So where was my example here? Was in my students. Created my temp table. And then I just insert the results of the procedure execution into it. That doesn't work in Fabric. This is not actually on the roadmap. I need to put in a request for this to get added. But again, your transformation logic is going to have to dump, not just dump it to, like my stored procedure can't just be a return a data set. It has to instead insert that into the temp table that I created in part one. Right. So yeah, same job, same solution, same drawbacks to watch out for as the other one. Limitation number 3 is not a limitation for me because I don't use the merge statement. I've seen too many situations where really large dimensions, the merge is very inefficient. So I won't use a merge statement. But for small dimensions, it works great every time. But I also like to have the same pattern every single one of my dimensions. I don't want to say, like use merges for the little ones, but my big student dimension use something else. I want to use the same pattern all the way around. So I have separate insert and update statements. I'm really, the thing you have to watch out for is handling those as a transaction. Like if you're, I'll do my update first before my insert. If my update succeeds and my insert fails, is that a problem? Right? Do I just rerun until the insert works, or do I only want those to commit if both succeed? Well, it's because this is a reporting system. It's not as simple as always saying, no, I don't want that to ever happen, like you would in a transactional system. But you do need to think about it. All right. Now the other limitation here, no identity conflicts. Right, I'm creating a new row in my fact table or a new row in my dimension table. On premises, my key is an identity column. Gives it a number or my, let me back up a second. My merge is supposedly coming this quarter as well. So yeah, if you're using a lot of merge statements today, maybe wait a month. So back to the identity. There's no identity columns. Right. So what I've got to do is use a workaround. So I've got an example somewhere here. So get my workspace. Now let's look at all the workspaces. Sorry. I think this is here we go. Hyde fabric. Get a warehouse called EDW. And I've got a stored procedure. This is my term dimension. Right. So I'm populating my temp table, which I may not have created yet. Populate my temp table, and then inserting that data. So let's so I've got some type any records that are in my source system. I terminate those. I do a soft delete. I don't delete them from the dimension completely. I just mark them as no and give them an end date. My temp 1 changes. I do all those updates. My temp 2 changes. Here I do the incidents. So what I've done is I've declared a variable called my row seed. And I do a quick query. Give me the largest value for my surrogate key within the dimension today. Okay? That's going to be my starting point. So, like you might on premises, this wouldn't be in my insert statement, right? I'm letting the insert statement give it the next key in the identity. But because we don't have that, I have to include it in my insert. I come down here, I take my row seed, and I add the row number function. And so this is going to give me a sequential number. I don't have a partition. So it will always be one of the duplicate. And I give it an order. Like, here's the order I want my records to go into, in this case, based on the term start date. And if there's terms with multiple start dates, which does happen in this college, or multiple terms with the same start date, then use that term code. So that gives me a new number for however many new terms they've added. Let's say they've created a year's worth of terms, which ends up being 6 terms. They have, 3 trimesters, each have a credit version and a non-credit version. So when I set up a new year, that's 6 new rows. This gives me numbers 1 through 6, and even assigns them to the rows in the order that I want them to go into. So that nice thing about that, we've got no issues here. Where the other limitations, we had some issues with the workaround. Absolutely not. So yeah, you get to use this without even really thinking about it. Good news on this, identity columns are coming. Yeah, you may think, okay, why are these not there? Right? We've had identity columns for billions of years in SQL Server, which is true, but they're not part of the Parquet specification because we're using that open source Parquet method to store the data. Parquet doesn't have identities. So yeah, Fabric did shit with the way it put identity columns in on an insert. Now that is coming again, hopefully this quarter. We've got Fabric coming up at the end of the month in Las Vegas. I'm guessing or hoping this is where all these announcements will be. Say, hey, this is generally available then. Or it might be, hey, we ran into some issues, we push that back to Q2 or further. But just know if you're going to lift and shift your existing code, that's some of the things you have to watch out for. All right, so this is my last tip about the warehouse. And it's that you can actually leverage a lakehouse. Right? This is, when we started talking about Fabric, a couple years ago, there was a lot of sort of all or nothing discourse. Right? You either have a lakehouse or you have, but why not both? Within the capacity that you have for Fabric, you just have a block of compute time. It doesn't really matter whether your data's in a lakehouse or 10 lakehouses or a warehouse or 10 warehouses. Now there's some connectivity bits, like we heard that directory doesn't work against multiple warehouses. Yeah, we got some gotchas like that, but for the most part, it's just storage compute. So what does the warehouse not have? It does not have file storage. Right? Like my on-premises data warehouse, I have a file share on that machine. Right? We're in the cloud here. We don't automatically have a file share to go along with my Delta tables in my warehouse. But if I'm using a lakehouse, the lakehouse does have that file storage. So maybe I use that lakehouse for my bronze lake, for my raw ingestion data. Maybe I even use it for my silver layer where I start to transform things but still leave them in the general shape. But then my gold layer, the one that all my SQL using analysts are hitting, that's going to be alarms. So yeah, mix them up. If I've got data warehouses in different workspaces, I have some difficulties connecting to those. So within a warehouse, I could use a 3-part naming convention. So warehouse name, schema name, table name, or warehouse schema view. But I don't have a 4-part naming. That would be one of like server, server database name, schema, table name, and the on-prem. I don't have that very first one for the 4. So if I've got data warehouses in different workspaces, maybe I've got a workspace for sales, a workspace for accounting, a workspace for marketing. I need to bring those together. What I can do is create one lakehouse, put shortcuts, those different warehouses in that lakehouse. And then I can use 3-part naming to refer to those tables as lakehouse, Lakehouse name, schema name. Okay.
So
There's lots of ways around things that just, the bigger point is your warehouse solution can also include a lakehouse for doing some of those extra pieces.
all right.
All right, so that is what I've got today.
Yeah.
It's just a short notice, and you can make this happen. We do have FabCon in Las Vegas a month from now. Where these great Microsoft speakers, and also me, will be speaking. So it's going to be 3 days of like 1 hour sessions like this. And you have 3 other days if you want full day workshops. Not too late to sign up here. I do have a discount code. I think as user group leaders, you've probably been already sent the $400 discount code. So there is a discount code available if anyone wants to, still sign up for that.
So
So here are the resources. So this presentation is in my GitHub. And you'll see like a different PowerPoint for every time I've given it. So you'll be able to go and download this one. I just need to like change over, a couple slides, but I'll have that uploaded shortly. And I've always had these two short links. Oops, that I've then taken away is a link to all the Microsoft Learn material, all their tutorials, all bundled up in one link. And then the Fabric roadmap. So if you want to follow like those features that I said are coming, follow that link. It will take you to this page. And from there you can dive into what's coming in Data Warehouse. Okay, here's my temp tables, here's my merge. Yep, Q1 still on track. Here's what shipped before. We didn't have truncated available until Q3 last year, for example. That's when that got shipped. So you keep up to date with here's what we've got, here's what's coming. Grid link to follow. And again, that was aka.ms/Fabric Roadmap. All right. So any last questions? I know I've thrown a lot of information at you all in the last hour and a bit. But if you have any other questions, come off mute or put them in chat, and maybe Brandon Wilson can relay them. Nice. Brandon's it combined you two instead of Brent and Wilson. It combined the two of you into Brandon Wilson.
Oh,
That's quite all right. So I'll have to refer to both of you as that way now. Yeah, I think thank you for presenting this very, very good information for the audience here. I think everyone's very appreciative of your presentation throughout. So thank you for your time there, Chris.
mhm.
Thank you for having me once again.